Hello, this is Mr. C, and the subject we're going to be talking about today is trig. Now, trig is a study of triangles, so forth and so on, but our study has to do with right triangles. And right off the bat, I'm just going to identify what a right triangle is. That is a right triangle. How do we identify a right triangle? Well, for one thing, it has right here, see this square I made? This is a 90-degree angle, and all the triangles we're going to be talking about have right triangles. They also have a hypotenuse, and I'm just going to say HYP for our hypotenuse there, and two other sides. Now, some things you should know. If I add up this angle right here, and I'm going to put a little symbol in, that's one angle. And let me draw it over here so you can see what I drew. It's that. And over here, I'm going to label this one with a different kind of symbol. That's our triangle. Well, all together, if I add up all these angles, the other thing we should know is this plus this plus the 90 we already have down here always equals 180 degrees. That's the first thing you got to know. Always equal to 180. That's our first thing. Our second thing, we're going to name these things, and you'll see it more as I go on. But for now, we're going to name these things the sides. We're going to give them names. Now, we already know what the hypotenuse is. And what we name these other two sides, this is the hype, right there, hypotenuse. What we name these other sides depends upon where we're looking from. If we are looking from this side right over here, okay, that angle right there, then the opposite side is going to be called opposite. And I'm just going to abbreviate that OPP. And the side right next to it is going to be called the adjacent side. And I'm going to abbreviate that ADJ. So that's the names we're going to have for those triangles. If I was looking at that triangle from this point over here, I'll put that other symbol here, this always remains the hypotenuse. It is the longest side all the time. It is always and forever the longest side. Matter of fact, I'm going to write that down. Longest side. Put that in your notes. And depending upon where you're looking from, remember back over here, right over there, we said if I'm looking from this angle over here, this is the opposite. If I'm looking from this guy right here, here's my eyeball. I'm going to show an eyeball over here. Oh, what a good eyeball that is. If I'm looking, this is the opposite and this is the adjacent. If I'm looking from here, and I'm going to put another eyeball. Isn't that a good eyeball? Okay, if I'm looking from there, then this side becomes the opposite. And this side is the adjacent. So what we call our triangles, and I've done this in class, so this is just a refresher, what we call our triangles depends upon where you're looking from, what we call the sides of our triangles. Now, I'm going to give you a hint as to how to remember what's what. I'm going to draw a big right triangle right over here. A huge right triangle. Okay, and as always, this guy is the 90. This guy is the hypotenuse. And I'm going to be assuming I'm looking from this angle right over here. And there's the symbol I'm going to use. Okay? Now, if I were a little guy over here, I'm going to draw a picture of a little guy. And he's kind of standing a little sideways. And this guy has nice long arms. Not too long, but long. If he is standing over here, then he can touch the adjacent side and he can touch the hypotenuse, but there's no way he can touch the opposite side. So if he's standing over here, there's no way he can touch that opposite side. Now, I did it in class with a rope, you may recall. And I had a big triangle across the whole room, and I demonstrated this in class. Let's do it one more time, except let's use the other corner. Now, I'm going to draw another big triangle again. There it is, a big triangle. I'm drawing it as well as I can with this little pad I'm using. And once again, we are going to assume that this is a right triangle, and here is the 90. As always, the longest side, and there always has to be a longest side on a triangle, on a right triangle, always, is going to be the hypotenuse. So that one's easy. But now I'm going to try and figure out what this angle is over here. There's the symbol for that angle. Now, once again, I'm going to put my little man in here. He's standing right here. There he is. Okay, and our rules say that he can touch the adjacent side, and he can touch the hypotenuse, but he can never touch the opposite side. And that's going to be how you're going to remember where the opposite is on this triangle, where the adjacent is, and where the hypotenuse is. Let's go on. Here are two triangles. Before I do anything, I want to take out this one that wasn't supposed to be over here. I'm erasing that, okay? Now, what do you notice that's similar about these triangles? Not exact, similar. Well, right off the bat, you may say, hey, they have the same kind of point here. This one has the same kind of point there as right here. Okay, I should have drawn the symbol like that. Okay? They have the same kind of similarities. Also, this angle here, and I'll use this symbol over here, is just as pointy as this guy. Now, they may not be the same size, or they may be the same size. Maybe this one's further back, and this one over here is further back, and this one's closer. But one thing we know for sure is that the points, this point is similar to this point, and this point over here is similar to this point. So they are similar. Now, we already identified that they are similar because they have the same kind of pointiness to them. And what this topic, we're going to go on and we're going to talk about ratios. Okay? And we'll explain what ratios are as we start to go through, but you'll see it pretty quickly, I'm sure. Okay, trigonomic ratios, right up here, are based on the concept of similar triangles. And don't forget what I showed you in the last slide. I had a triangle that kind of looked like this, and I had one that was bigger but had the same shape. That is to say, this point here was the same as this point, sharpness. It was just as sharp, as was this point over here, just as sharp as this one over here. So similar means they have kind of the same shape. Okay, let's go on. Now remember my first slide, I said that triangles always have something in common. One of the things you may recall was that they always equal 180 degrees. So right off the bat, if we know this is 90, okay, meaning it's perpendicular, and sometimes you may see a symbol like this, meaning that this is 90 over here and this is 90, Then we have 45, 90, and in order to equal 180, this guy has to be 45 too. And you can add them up and find that out. Okay, so we know that about these triangles. But what's the idea of the ratios we talked about last time? Well, that's what we're going to check next. I'm going to put a little something over here that we will talk about later. I'm going to put something called so ka and toa. Now right now this is for me. You'll know what this is later when I talk about it. But I'm going to keep that up there. And let's see. I'm going to go on and describe what we were talking about the ratios. Now, if I am talking about this guy over here, the first thing I'm going to do is label him. I know from the last slide that this is the opposite over here. OPP I'll put. And this guy over here is the adjacent. And I'm going to be talking about this again over here, this guy. So this is again is the opposite. And the one down here is the adjacent. So far so good. And lastly, the last one, again, if we're talking about this point right here and we're looking, this is the opposite side. And once again, the one right next to this 0.707 is the adjacent. Now we've labeled these guys. Now, I want to show you something. I want to show you that if I take and divide the opposite by the hypotenuse on all three of these triangles, here's what I get. Okay, I'm going to divide one over here. The opposite of this guy right here is 1, and the hypotenuse is 1.414. So I'm going to divide 1 divided by 1.414, and I want to see what I get. Got the old calculator on. 1 divided by 1.414, and I get a number that is 0.707. Okay, this is going to be equal to 0.707. All right, so we know if I divided the opposite divided by the hypotenuse, and don't forget this is the hypotenuse over here, I'm going to get 0.707. That's the ratio of the opposite side to the hypotenuse. Well, okay, what am I going to get on the big triangle to your right? Well, let's see. In this case, I'm going to divide 2 divided by 2.828. This is a 2. Well, let's see. 2 divided by 2.828. Well, guess what? I get 0.707 again. And do it yourself. If you do the last one, I'll put it out over here this time. I'm going to divide 0.707, which is the opposite side of this guy down here, and I'm going to divide it by 1. Well, we don't even need the calculator for this. This is going to be equal to 0.707. So with all these similar triangles, when I divide sides, the answers are all the same, regardless if it's a big triangle, a small triangle, or a medium-sized triangle. Now, this is the same thing. Okay, each one of these triangles at first appears to be different sized, but they have something in common. One thing they have in common is all of them equal 180 degrees. Okay, when you add up all the angles, even though they're different sizes. The other thing they have in common is the ratio of sides. If I divide the square root of 3 divided by 2, okay, it's going to be equal to this guy's 2 square root of 3 divided by 4. And that's going to be equal to this guy's over here, his square root of 3 divided by 2, divided by 1. They're all going to be the same answer. Well, let's try and see what happens. Let's check that out. Okay, first, square root of 3 divided by 2. Square root of 3 divided by 2. I get 0.866 for this triangle. 0.866. Okay, how about the next one? Square root of 3 times 2 divided by 4. Well, what do you know? This guy over here is equal to 0.866. And I can tell you right off the bat, the square root of 3 divided by 2, the whole thing divided by 1, is going to be equal to 866. So the ratio of these sides, regardless of the size of the triangles, when you divide sides by other sides, in this case the opposite, if we're looking from here, this would be the opposite, and this would be the adjacent down here, if I'm looking from the 60. And this is the hypotenuse. If I divide the opposite by the hypotenuse on each one of these triangles, I get 0.866. Okay, I told you our rules are that if I make a mistake but catch it before you do, then I get the points, and if you catch it before I do, then you get the points. I should have said for this triangle down here that if I divide square root of 3 divided by 2 and divide that whole thing by 1, again, from this point, that would be the opposite over the hypotenuse. I will get 0.866. Now, there's certain ways we divide these sides, and I'm going to put up over here in the corner, S is equal to the opposite over the hypotenuse. C, and don't worry about what S and C is for now, is equal to the adjacent over the hypotenuse. And T is equal to the opposite over the adjacent. Now you already know how to label the sides, so just decide on where you're going to look from, and I suggest you start looking from these corners first and try it. See if all the ratios come out to be the same for these similar triangles. You'll find that they do. So first divide all the opposites divided by the hypotenuses. Then I want you to divide all the opposites on every one of these things divided by the adjacents. Again, we're looking from this point right here. So on all these guys, this is the opposite, and these are the adjacents down here on all triangles, on all the triangles. And you're going to see the numbers come out the same. Let's do one more. Let's also divide the adjacent on all these guys divided by the hypotenuse. Okay, and you're going to find out that the ratios on this guy are the same as the ratios on this guy are the same as the ratios on this guy. Well, this is what it means. And this happens to be using the tangent ratio. Okay, and the tangent ratio says tangent is equal to the opposite over the adjacent. And what this is saying is if two triangles are similar in shape, which you can see that this one is similar to this one, this says that if on this guy over here, A is divided by B, you're going to get the same thing as this guy's A prime divided by B prime. It says that this guy is going to be equal to this guy. And I think we've done that pretty well. The ratio A and B is called the tangent ratio for this angle right here. And again, we're talking from this point right here, so therefore this would be equal to the opposite over the adjacent. Now, we did this in class. I know this is just a tutorial, but if you're following your notes, you should see where this is coming from. And once again, it says the ratio A over B is called the tangent ratio, also called the opposite over the adjacent. Okay, here we are to a blank screen. And I'm going to do the same thing again. I'm going to pretend I don't know what this is. I don't know what that is, or this, but all I had were two sides, and I wanted to find the angle. Once again, I'm going to be looking, in this case, from this side, from that angle, which would make this guy the adjacent, ADJ, and this guy the opposite. I want to find out what this angle is. Well, now I'm still using the same thing because I have an opposite and an adjacent. I'm going to be using the tangent of the angle is equal to the opposite over the adjacent. Toa, the Indian tribe Toa. But now it's going to be opposite over adjacent. Well, what is my opposite? My opposite happens to be the square root of 3 for this triangle over 1. That's my ratio. And the square root of 3 is 1.73. Let me just check that again. Yep, 1.73, and I'm going to divide that by 1, which is 1.73. Okay, so now it's 1.73. That's my ratio. And I'm going to go in here into my calculator, and I'm going to hit the inverse tangent on my calculator, and guess what it comes out to? The inverse tangent, that is the tangent minus 1 on my calculator. On my calculator, I press the tangent minus 1 key of 1.73, and it comes out to 60. Okay? Remember, in each of these cases, we are pretending we have this guy and this guy. That's all we know. And this guy and this guy. In the next frame, we're going to pretend we have two other numbers. Okay, let me erase some numbers first. I'm going to pretend that this time I don't know the angle. I'm going to be looking for him. And I don't know this side. Now, which angle would you like to look from? It makes no difference whatsoever. Okay, let's say this time we pick up right up over here. We're going to be looking for this angle up here. Well, if I do, you already know that makes this side the opposite, this side the adjacent, and this side the hypotenuse, as always, because it is the longest side. Well, now I don't know what the opposite is, but I know what the adjacent hypotenuse is, and I go back to my SOHCAHTOA. SOHCAHTOA. Now let's see, I got a hypotenuse, which means this guy and this guy are possibilities, but I don't have an opposite, which means this guy's no good.
So the only one left is the ka. So now I write out the formula. The cosine of the angle, not the angle itself, but the cosine of the angle, is equal to a ratio of the adjacent, I'm just putting down single letters now for space, over the hypotenuse. All right, adjacent over the hypotenuse. Well, that means it's going to be equal to 1 over 2. And 1 over 2 means that the cosine of the angle, that ratio, is equal to 0.5. All right, now that's the cosine of the, that's the ratio. And if you try this guy, since they're all similar triangles, they all come out to a cosine of the angle equal to 0.5. Try it. This guy down here, remember, we don't have this, we don't have this, we don't have this. All we have is this, this. They all come out to a cosine of the angle of 0.5. Now, in order to find the angle, I go to my calculator and I say angle is equal to what we call, there's a key on your calculator, cosine minus 1, and I plug in the 0.5, and guess what I get? I get an answer equal to, my calculator says 60. That stands for 60 degrees. Now these are going to take some practice, but I will show you in class that no matter what you have, all you need is two things to find everything out about the triangle. And we'll do it more in depth in class. So again, these are intended to supplement your notes, not to replace them. Now, as it says here, there are a total of 6 ratios that we can have in total, but we only talked about 3. So I'm going to take this out, and I'm going to replace it with 3. And they are so katoa, right? So ka and toa is already shown above. And the opposite side in this particular picture, because we're looking, this angle is shown here, is just as shown. A good way to remember is, as I said before, Sokatoa, like an Indian tribe. And it stands for the sine of the angle, not the angle itself, the sine of the angle. The sine of the angle is a ratio, not to be confused with the angle. The cosine of the angle is the adjacent over the hypotenuse, and the tangent of the angle is the opposite over adjacent. Okay, I thought I had taken out these numbers over here. Bear with me a second. I want to do some white erasing here. I thought I had taken out these numbers before, but I apparently forgot. I make mistakes too, see? So I'm going to take these numbers out. And the only reason the triangle's there is to show you that we are dealing with a triangle. Now here's our problem. We want to figure out the height of this tree. And we can march off and count off 53 feet over here. And then when we're standing here, we look up and we have a little protractor, and we can figure out that we are looking up here at an angle of 60 degrees. And we want to know the exact height of this tree. That's going to be our problem. So let's write down what we have. Let's take this triangle over here, and let's write that we have 53 over here, Okay, we got 60 over here. I'm going to put the 60 down here because it's kind of a small triangle. That's our angle, 60. And that's all we know. We know two things. Well, that's not quite all we know. We also know, looking from the 60-degree angle mark right there, we know that this is our opposite side. Okay. And we know that the 53 is our adjacent. And I'm just going to put down an A so it doesn't get too busy. You know that stands for adjacent. And I'm going to put an H over here for hypotenuse because you know that stands for hypotenuse. Okay. So we know two things. And plus the 90. I didn't mention the 90, but I'm just going to put a dot. You know the 90's there. So we have we have an angle and a 53. Let's write down what we have. We know our angle, and sometimes you'll see me do this in class. Kind of looks like an angle, doesn't it? Our angle is 60. Okay. We know that our adjacent is 53. It's 53 feet. Understood to be 53 feet. I'm not going to busy this thing up by putting the feet in. 53 feet. And we're looking for our opposite. We want to know how high that tree is. Opposite, OPP. Well, I'm going to draw on top the only formulas we know to try and find this. Okay, we got SOHCAHTOA. So, Ka and Toa. Well, let's see. We're looking for the angle, so we got to start off by finding a ratio. So all three have a ratio in them. We've got the sine ratio, the cosine ratio, and the tangent ratio that we can look up in a book and find the actual what the ratio is. Now we have an angle, and we're looking for the opposite. Which one of these has an opposite in it? Oh, so has an opposite. Oh, but wait a minute. So does not have a hypotenuse. We don't know what the hypotenuse is, so we can't. We need two things. Okay, since the cosine doesn't have an opposite in it, that's not going to help us. The only guy left that might be a help as to figure out how to solve this is the tangent. And we know if we write it out, we know that tangent, I'm just going to put T for now, only because this is getting too busy, this thing. Tangent is equal to the opposite over the adjacent. Okay, but we're not looking for opposite over the adjacent. Let me write that down. That's the A. Okay, now we know the adjacent and we know the angle, but we don't know the opposite. So I'm going to cross multiply to solve this. Okay, I end up with A, and I'm going to write the whole thing out now, times the tangent of the angle. Remember, the tangent of the angle is a ratio from the other slides. Tangent of the angle is going to be equal to the opposite. I'm just going to put O because I'm running out of space. All right. Well, now, what's the tangent of the angle? Well, here's the angle. If I plug into my calculator the tangent of 60, okay, I plug in, let's see, turn the calculator on, 60, press the tangent button, and I get 1.73. All right, so now I know my tangent, okay, of that angle is equal to 1.73. So now I'm going to plug it all in and multiply it out. I'll write the formula down first. A times the tangent of the angle is going to be equal to the opposite. And the opposite's what I want. And when I plug that all in, I've got 53 . times, here's a little time sign, 1.73 times 1.73 is going to be equal to 91.8 feet. That's how tall that tree is, 91.8 feet. And now I'll put that last symbol in. Okay, so that we figured out just from two things how tall that tree was. Okay? Review it. Go back, look at what we did.